So see, in OSI model we have 7 layers: application, then presentation, then session, right? So on the PC guys, first layer is application layer, last layer is physical layer, right? So as I am trying to access web page, and to access web page we have two types of protocol. One is HTTP, another one is HTTPS. How this machine will get to know I need to use which protocol, HTTP or HTTPS? At application layer, I have typed www.pmnet.com in the browser. I hit enter. Machine have resolved IP address for this domain name, and my machine got the IP address, that is 8.8.8.8. Now which protocol will use, and how machine will get to know which protocol I need to use? This is what complete URL. And which protocol my machine is using? HTTPS, Hypertext Transfer Protocol Secure. So HTTPS is an application layer protocol which is used to access web page. Getting my point? HTTP is also a protocol, application layer protocol, which is used to access web page. Use of both protocol is same, accessing web page from web server. The difference is HTTP is not secure, HTTPS is secure, right? So if you will type HTTP pmnetworking.in, that means your machine is using HTTP protocol, means port number 80. If in the URL, if you will type HTTPS, then your machine will use HTTPS protocol. Is it clear? So actually your machine have already knowledge guide. Modern devices always sends traffic through HTTPS protocol. Always use HTTPS protocols, right? And this is not sure that we are only using HTTPS. We are not using HTTP. Let's say I have some books on my server, right guys, and I want to give you access so that you guys can download the book or you can read book on my application. So I can use HTTP as well here. But if there is some critical resources, critical applications are there on application, then definitely I should use HTTPS. Let's say the server is bank server of a bank, should always use HTTPS protocol to access their web page. So if you are transferring money guys, make sure your protocol is HTTPS. You have to put the complete URL, means first protocol and then domain name, that is URL. But guys, nowadays browser have already capability to detect the protocol. So once you will type the domain name google.com, your browser already know, oh, okay, for Google I am going to use HTTPS protocol. Any question? Yes. Don't worry about the email now. First try to understand the web page. Now we'll talk about the email as well. Like right now I am talking about web page. In the same way we will discuss about email service as well. And not only email service, we have multiple more services. No, brother, DHCP is there, DNS is there, file transfer is there. Lots of services are there. We will discuss all services one by one. Is it clear how we are accessing web page, guys? So for my browser, for this browser, by default protocol is HTTPS. That's why it have used this protocol automatically. Done. In your scenario, by default protocol can be HTTP also, or manually you can change it. See, if I will remove S from here, see, still I have access of my website, and now you can see it's still using HTTPS, right? If I'm trying to change the protocol, guys, see, my browser is automatically using secure protocol, HTTPS protocol. This is capability of my browser. browser configuration, and this interface is application layer. This interface is application layer, because with the help of this interface I can access any web page, right? This is also one what? Interface. This is also what? One interface. Through this interface I can send mail. Getting my point? So application layer is responsible to provide user interface. This is first task of application layer, and we have many services at application layer. To access the services we have different type of protocols. To access web page we have two protocol. One is HTTP, another one is HTTPS. And your browser is going to detect the protocol automatically, right? And your browser is going to detect which protocol. It depends on browser configuration. In your operating system, this browser is installed inside operating system, right? So it depends on the configuration, guys. Configuration of this app, this application. Now this is my complete URL, pmnetworking.in. Now this machine have complete URL. Now this machine is going to find IP address of this URL, right? So again at application layer we have now another service, that is domain name to IP resolution service, you can say, which is going to resolve domain name to IP address. So name to IP service, name to IP service at the same layer, right? And which protocol? Again I need one protocol to use this service. So the protocol is called DNS, domain name system. So now my machine have URL, that is www.pmnetworking.in. Not this one, complete URL is this one. So my machine is going to call DNS server, and it is going to tell to DNS server, brother, please find the IP address of this domain name. So DNS protocol is going to see, protocol have capability to generate message. So now DNS protocol is going to generate a message that is called DNS request message. DNS request message. Again to forward this DNS message, it need address, source IP, destination IP, source MAC, destination MAC, yes or no? Without address this machine cannot send this message. So DNS protocol is going to generate DNS request, and under the request, guys, what will be the information? What is the IP address of this domain name, right? So see, in the packet tracer I am going to design one lab. Let's suppose I have one switch here, and then I have some end devices, computers are there, PC1, let me remove the PC0, it will confuse, PC1, PC2. Is diagram visible? Right, both devices are connected with this switch, and then switch is connected with a router. So I have one router here, router, let's suppose R1. Then again I have, let's suppose, one switch here, and now this switch is connected with one server. Which server? pmnetworking.in server. Which server? pmnetworking.in. Which type of cable it is, guys? Like this. This is my network. So how these user can access web service which is available on this server? Let's suppose PC1 IP address is 192.168.1.1/24. PC2 IP address is 192.168.1.2/24. Both belongs to same network or different network. Router interface IP address is 192.168.1. Let's say 100, or last IP address 254/24, and the server IP address is 192.168.2.1/24, and this interface IP address is 192.168.2.254/24. So I'm using last IP address for default gateway. Right. So let me configure the router. Only I need to configure IP addresses here. Just a minute. Interface F0/1. Which interface is 0/0? Okay, 0/0 is connected with server. Fine. So 0/1 no set and IP address which is connected with my LAN network. So here I'm going to define 192.168.1.254.255.255.255.0. Exit. Then interface F0/0 say no set, and on this interface I need to configure one IP which is 192.168.2.254.255.255.255.0. Exit. Right. Let me save the configuration. Router configuration is done. Now I am going to configure IP on PC1. PC1 IP address is 192.168.1.1, or I can configure the DHCP service as well on router, but let me configure IP manually now. 168.1.1 subnet mask 255.255.255.0, and PC2 IP address is 192.168.1.2. default gateway is this one. Server IP address is 192.168.2.1, this one. Now guys, see, whatever services are available on the server, whatever services, let's suppose multiple services are available like HTTP, HTTPS, right? Then DHCP, DNS, right? FTP means file services. Lots of services are there. And guys, if these users want to access any services, first requirement is there should be IP reachability. IP reachability means these devices should be able to ping this server. IP connectivity must be there. If there is no connectivity, then these devices cannot access the services. Yes or no? Is it clear to all? If you are able to access google.com, that means there is IP reachability between your device and Google server. Without IP reachability, you cannot access any services. So is IP reachability there? Can these devices ping to server now? I have configured IP addresses on all the devices. Tell me guys, can PC1 ping to server? Why? Yes, yes. To communicate with any device belongs to different network, default gateway is required, right? These PC need default gateway IP address. See, if I will ping PC2, ping 192.168.1.2, I can ping is working, I am getting reply, but I cannot ping 192.168.2.1 server. Now why default gateway is required? Anyone? Why default gateway is required? Why, brother? Oh, why default gateway is required here? Oh my god. Why default gateway is required? Without default, see, if I am pinging to this IP address, tell me which device is dropping the traffic. Why I'm not able to ping this IP address? Private IP address. See, if PC1 want to forward any message to this IP address, PC1 need MAC address of this IP address, yes or no? And can PC1 find MAC address of this IP address? No. Because to find MAC address from IP address, it is going to generate ARP. ARP is a broadcast message, so router will not forward that broadcast message, right? Router will drop it. So this is why default gateway is required on PC1. Because PC1 cannot resolve MAC address of server, because server belongs to a different network. So if you are pinging to this IP address, this PC need MAC address. And see the ARP table, so ARP. Is there any entry? What is command guys to check ARP table? This one. See the ARP table. There is only one entry. MAC address of PC2. Why we don't have MAC address of server? Because this PC cannot resolve MAC address of server. Server belongs to different network. And router break broadcast domain. So in this scenario, there are two broadcast domain. One is this one and one is this one. Means broadcast message of this domain can travel between these devices only, and broadcast message in this domain can travel on these devices only. Broadcast message of this domain cannot enter in this domain, right? Broadcast domain 1, broadcast domain 2. So if this PC will generate a ARP request message for this IP address, so as ARP is a broadcast, it will forward to switch, switch will forward to router, and router is going to drop it. So that's why default gateway is required, so that whenever this user will communicate with server or with any device belongs to different network, destination MAC will be the MAC address of default gateway. Destination MAC will be not the MAC address of destination device. So if PC1 is pinging to PC2, destination MAC will be MAC address of PC2. If PC1 is pinging to server, MAC address will be the MAC address of default gateway. Correct? So here default gateway is required. On PC number 1, I need to configure default gateway. So let me configure the default gateway. What is default gateway IP address? 192.168.1.254. Now can I ping to server? Now see guys, ARP, we don't have MAC address of default gateway, but this time if I am going to ping server 192.168.2.1, ping is not working, but this machine will have MAC address of their default gateway. Now tell me why this machine is not able to ping. Yes, server does not have default gateway this time. And now if you will check ARP table of this PC, see you have MAC address of your default gateway, right? So every time whenever this PC will forward traffic to any user belongs to different network, destination MAC will be always this one, right? So still I am not able to ping server because this server don't have default gateway. So server is not able to forward the reply message. So here also I need to configure default gateway 192.168.2.254. Now can PC1 ping to server? Yes guys, can now PC1 ping to server? See, will ping work this time? Yes. Now I ping is not working. Let me check the server IP address. So default gateway is incorrect. 254. See, ping is working. Now I am getting reply. In the same way, PC2 can also ping server. I need to configure default gateway here. That's it. Now guys, there is IP reachability. Now if I have some services on the server, this user can access it. Right? So let me enable HTTPS service here. So go to services section, and in services section you can see HTTP protocol, right? So you have two protocol here. One is HTTP, this one, and one is HTTPS. And guys, by default both protocol are on. Yes or no? HTTP is on, HTTPS is also on. So both services is by default running on the server, right? If you want to see the coding, see the coding in HTML. This is my website coding. I can change the name to PM networking. Welcome to PM networking, like this. If you know the coding guys in HTML, then you can change the color, or you can design the website here, right? Let me save the, I have changed some coding here and then I have saved it. So HTTP service is running there. Now can I access web page from PC1? Tell me yes or no. Go to the browser and just type www.pmnetworking.in, www.pmnetworking.in. Why I'm not able to access web page. See, host name unresolved. What is the issue, guys? This machine is not able to resolve this domain name into IP address. Why this machine is not able to resolve this domain name into IP address? Because this machine, yes, because this machine don't have IP address of DNS server. So see, this machine have IP address, this machine have submit mask, this machine have default gateway IP address, but this machine don't have DNS server IP address. Yes or no? So let me do one thing. Let me add one more server here. I'm going to add one more server here, and that is my DNS server. Let's say this is my DNS server. And DNS server IP address is 192. DNS server IP address is 192.168.2.2/24. Done. So go to DNS server and let me configure the IP. 192.168.2.2. Default gateway 192.168.2.254. And now I need to tell to PC1 that IP address of DNS server is this one, 2.2. So let me say DNS server IP address 192.168.2.2. And guys, again, DNS server should be reachable. Means there should be IP reachability between PC1 and DNS server. So can this server, this PC ping to DNS server? You can check. Ping 192.168.2.2. Will ping work? Yes, ping will work. Why ping is not working? DNS server have default gateway 192.168.2. Sorry, IP address is 2.2, not 1. Both machine had same IP address 2.1. Okay, now you can ping. See, ping is working. Can now I access server, means web page? Can I access web page, guys, now? Let me try. www.pmnetworking.in. See, this time what is the issue? This time it is not giving me error name not resolved. This time issue is different. If this machine don't have DNS server IP address, guys, then it is going to give you different error. If I will remove it, and then if I will type URL in the browser, I will get what error? Any domain name, see, host name unresolved. But if I will define the DNS server IP address, then it will not give you this error. DNS server IP 192.168.2.2. Now my PC have IP address of DNS server. PC have already sent the request to DNS server www.pmnetworking.in. Now what is the issue? This time, guys, issue is, see, can I access this server, means web page, through IP address? IP address of server is, guys, 192.168.2.1. So yes, you can see with the help of IP address I am able to access the web page. Correct? But with the help of domain name I am not able to access it. The reason is DNS server don't have IP address for this domain name. See, if I will type this domain name in the browser, what will happen? Hit enter. My machine have generated one packet. Which type of packet it is? DNS, right? So if you will open it, see, the source IP address is IP address of PC1, destination IP address is IP address of server. Correct, guys? DNS server. Source MAC address is MAC address of PC1, destination MAC is MAC address of default gateway, because DNS server belongs to different network. Correct? Source port is random port number. We will discuss about the port number later. Destination port is 53. So 53 port number is reserved for DNS, right? And which type of message it is? It is DNS query message. Okay, so this PC will forward this message to switch, switch will forward it to router, router will forward it to switch 1, switch 1 will forward it to DNS server. Now DNS server is going to generate reply, but in the reply, this is guys negative reply. DNS server can send two types of reply, negative reply or positive reply. Means whenever DNS server will receive a request for IP address from domain name, DNS server is going to check their local database, right? If entry is available in their local database, then DNS server is going to provide IP address to the client machine. If entry is not available, then it is going to generate negative reply. Even you can tell to this DNS server about secondary DNS server. Let's suppose there is one more DNS server guys somewhere in your network. So you can tell to your DNS server that whenever you will not found any entry in your database, then please ask to this DNS server. Please ask to this DNS server. So this DNS server is going to, whenever it will receive a request for IP address, it will check their database. If entry is not available in their database, then it is going to ask to another DNS server. Like this, you can have multiple DNS server IP address, multiple server in your network. You can tell different server IP address to this DNS server. This is DNS2, DNS1, this is DNS3, right? So if DNS server have IP address guys, then it is going to generate positive reply. If DNS server don't have IP address in their database, then it will generate negative reply. On the internet, how many root DNS server are there guys? See, whatever services are available on internet, those all services are maintained by DNS server, and that DNS server is called root DNS server. That DNS server is called root DNS server. Like if you are creating one website for your company, like I have created one website for my company and my domain name is pmnet.com. So on the internet, total there are 14 root servers. So on this root server guys, ISP is going to make one entry in their DNS database. The IP address of pmnetworking.in is my public IP address is 8.8.8.8, right? So simply I can tell the IP address of root DNS server to my DNS as well. But whenever you will not find any entry in your database, please ask to root server. So in the real time, you will have multiple DNS server for backup, right? To store lots of entries. So this time DNS server is generating one negative reply. And see, this is also unicast message. This is also unicast message. Source IP address is the IP address of DNS server, destination IP address of PC1, source MAC is the MAC address of DNS server, destination MAC is the MAC address of their default gateway, right? IP header, Ethernet header means layer 2 information, then layer 3 information, IP protocol is working, at layer 2 Ethernet protocol is working, then ICMP protocol is working, then UDP protocol is working, after that DNS. So this is actual message, DNS message, right? So you don't need to learn these applications, these guys codings, like how DNS have designed, what information DNS protocol is going to send in DNS request message or in DNS reply message. You only need to understand the function of DNS, like what is DNS, how DNS works, how you can set up DNS in your network, how you can set up multiple DNS in your network, and then how you can create entry. So like my organizations have one HTTP server, so I need to create one entry on this DNS server. So again I will click on this DNS server, then go to services, and see here I have DNS service. And guys, by default service is on or off? Off, correct? So I'm going to turn it on and see, is there any entry? No. I am going to create one entry. So what is domain name? Domain name is www.pmnetworking.in. What is the IP address for this domain name? IP address of this domain name means IP address of HTTP server. This is DNS server, guys. On this DNS server, I am creating one entry. So what is IP address of pmnetworking.in? 192.168.2.1. Like this, if you have multiple servers or multiple services you are running, so you can create entry for all servers here, right? After that, you can add it. So now you can see in the database, there is one entry. So if someone will send DNS query for this domain name, now this DNS server can send IP address, correct? Correct, guys? So this time again, I am going to open same URL in my browser. See DNS request message. It will forward to server. And now server is going to generate reply. Right? This is DNS reply message. In the DNS reply message, guys, it will say here IP address of pmnetworking.in. Here we are not able to see that. DNS header, here we see name PM networking. So this time this server is going to provide IP address to my client machine, and now guys, my client machine is going to add this entry in their cache memory, right? It will store this entry for some time in their cache memory, in the buffer memory, you can say. So when you will access again pmnetworking.in after some time, then your PC is not going to generate DNS query message for DNS server. First, your client PC means PC1 is going to check their on cache memory, right? On DNS database. If entry is available there, then it will pick IP address from there. If entry is not available there, then only it will send DNS query to DNS server. Is it clear to all? And now you can see I am able to access this server with domain name or not. Yes or no? Yes, now I can access the service with the help of domain name. Okay, so both services working on, guys, which layer? Application layer. Both are application layer services, DNS as well as yes HTTP. Now let's say, yeah, that again depends on your operating system. You can check na DNS entry timer in Windows 10 or Windows 11 or in Windows operating system. It will be different in Windows operating system. It is going to be different in Linux. It is going to be different in Cisco. Whenever a PC need IP address of a domain name, first it will look up their own database. If entry is not available in their own database, then only it is going to request to DNS server. Now guys, let's say like PC1 and PC2, I have 1000 number of devices here. Not 1000 because here I have only 254 valid IP addresses. So let's suppose I have 200 PCs are there, and all PCs need IP addresses. So if I will configure IP address manually on all PCs, then there is a chance of mistake, chance of duplicate IP as well. You can configure same IP address on multiple devices. You can configure wrong subnet mask. You can configure wrong default gateway, because you need to configure multiple things: IP address, subnet mask, default gateway IP address, DNS server IP address. Yes or no? So you can set up a DHCP server here. The third service is DHCP, right? So I can add one more server here, and this server is my DHCP server. So what is DNS? DNS is one application layer protocol, or you can say application layer service, which is responsible to resolve IP address from domain name. Like guys, you know why we have DNS? Because you cannot remember the IP address of each website. Is it possible to remember mobile number of your all friend? You know the name of your all friend, but you don't know the mobile number. So remember name is easy as compared to remember number. Yes or no? So that's why in mobile, what we have, guys? Phone book. So we can save a number with name, like PM networking. Mobile number is 8511826341. Oh, it is complicated to remember, but I can remember the name, that is PM networking. I know the name, but I don't know the number. So I can save it in phone book. So phone book is what? One database where you are storing name with number. DNS is also same thing. right? So DNS stands for domain name system, which is responsible to resolve IP address from domain name. Now next service is DHCP, Dynamic Host Configuration Protocol, which is responsible to provide IP addresses to machine dynamically. See, it is clear with your name. Dynamic, DHCP stands for Dynamic Host Configuration Protocol. Host Configuration Protocol. So configuring a host dynamically is known as DHCP, right? So let's suppose DHCP server IP address is 192.168.2.3/24, correct? And guys, this server is responsible to provide IP addresses to end devices. So I'm going to configure IP on DHCP service server first, and then I will enable DHCP services here. So go to desktop and let me configure the IP 192.168.2.3, subnet mask 255.255.255.0, default gateway IP address 192.168.2.254, last IP address. Is DNS server IP address required here? You can configure, you can ignore it as well, but let me configure it. 192.168.2.2 is the IP address of DNS server. And now guys, I am going to configure DHCP service for my network, for this network, right? Let's say both can be at different location. Let's say server room is in US and this private network is in India. Both are connected through internet. As I told you, to access the services, requirement is there should be IP reachability. That's it. So in upcoming days, you are going to learn how to make reachability, IP reachability between different locations, between different branches, between different buildings, between different devices. We will have lots of classes for this. So for now, just assume both are connected. There is IP reachability between both network. So if there is IP reachability, that means these devices can access the resources on this server. So I am going to enable this service here on the DHCP server. So go to services and see here you have one DHCP service, guys, and by default it is on or off, enable or disable. By default disable. So let me enable it. And now I'm going to create one pool here, so you can define the name of pool. Let's say pool name is CCNA. And then guys, what default gateway IP address the server is going to provide? 192.168.1.254. This will be the default gateway IP address for all these users, yes or no? Correct? Okay. Now, DNS server IP address. What DNS server IP address this DHCP service is going to provide? This DHCP server is going to provide 192.168.2.2. Then guys, starting IP address. What will be the starting IP address? 192.168.1.1, right? Subnet mask 255.255.255.0. Maximum number of user 253. 253, because I have already used one IP address here, that is 1.254. So total number of IP addresses in this network is 254. I have already used one, so I am going to provide 253 IP addresses to end devices. That's it. Now I need to add it and save it. That's it. Now you can see you have one entry here on this DHCP server. Now guys, can these devices get IP address from DHCP server? Yes. Now you don't need to configure IP manually, right? Let's suppose here I have one device. So can this device get IP address from DHCP server? Yes. How? Just click on DHCP here, right? So see, you have two methods to configure IP here. One is static, means configure IP static, default gateway, subnet mask, DNS server, everything statically. Other option is DHCP. So once I will click on DHCP, it is going to generate one broadcast message. Why broadcast message? See, this is not correct IP address. This is why, because DHCP server is unreachable for now. See, what is happening this time? This PC need one IP address, right? Through DHCP server, correct guys? This PC know where is DHCP server? This PC have information about DHCP server or not? Tell me yes or no. No, because this PC don't have any identity till now, right? You have not configured anything. That means definitely this PC is going to generate broadcast message, because this PC don't have information about DHCP server, and this PC need IP address from DHCP server. So it will send a broadcast message and router will drop that broadcast message. Yes or no? In DHCP, we have 4 types of message. DHCP work on DORA process, right? We will talk more about DHCP later, but for now, just understand the basic things. DHCP work on DORA process. DORA stands for discover, yes, discover, offer, then reply, sorry, request, and then acknowledgement. So discover means discover the DHCP server. How? With the help of broadcast. Offer means when DHCP server will receive the discover message, DHCP server is going to offer IP address. Request means again client machine is going to request for that IP address, and then server is going to acknowledge it. Yes, you can use it. After that, client will assign that IP address on their interface. So in this scenario, why this PC is not able to get IP address from DHCP server? Because this PC will generate discover message first, and router is going to drop that discover message. If you want to see, I can show you. Again, open the simulation mode and just type on DHCP again. Which type of message it is? DHCP, right? So if you open it, see guys, source IP address is 0.0.0.0, because this machine don't have any IP address. Destination IP is 255.255.255.255, means broadcast. Source MAC is the MAC address of PC, destination MAC is broadcast, right? So my client machine will forward it to switch will forward it to router, but as it is broadcast, router is going to drop it. Getting my point? These are another messages. Okay, so actually we can do one thing. We can tell to my router that, brother, whenever someone will send you discover message, don't discard it. Please forward it to 192.168.2.1, right? So you can configure this router. You can tell to this router, brother, I know you cannot forward a broadcast message, but you can do one thing. You can convert that broadcast message into unicast message, right? But you have to tell IP address of DHCP server to your router. So that is called helper address on this router. Simply I can say interface F0/1, which is connected with end devices. Say IP helper address, means IP address of DHCP server 192.168.1.3. That's it. Now my router know, oh, 2.3. Now my router knows DHCP server. So whenever this router will receive discover message, it will convert, it will make it unicast, and then it will forward to DHCP server, because router cannot forward broadcast message. So see, this time again, if I will type on DHCP, it will generate discover message, it will forward to switch will forward it to router. And see guys, router have generated one new message, right? First it have generated the ARP to resolve the MAC address of DHCP server. Sorry, let me open the simulation mode and click on DHCP. Yes, it will forward to switch will forward to router. And now router know the DHCP server, so it will convert this broadcast message into unicast. See this packet. Destination IP address is what, guys? Yes, destination IP is unicast or broadcast? Unicast. Source IP address is IP address of router, right? Source MAC is MAC address of router exit interface. Destination MAC is MAC address of DHCP server, correct? This is what this router is going to send, and this is what this router have received. So when PC have sent the discover message to router, destination was broadcast, source was 0.0.0. Source MAC was the MAC address of PC, destination MAC was broadcast. When router is forwarding it to DHCP server, source IP is the IP address of router, destination IP is the IP address of DHCP server, source MAC is the MAC address of router interface, exit and destination MAC is MAC address of DHCP server. Clear? Right? So now this router is going to forward it to DHCP server. And guys, which type of message it is? Discover. Now router is going to generate which type of message? Offer message. For whom? For router. Right? Destination IP 192.168.1.1. Source IP address of DHCP server. Source MAC address of DHCP server. Destination MAC address of router. All PCs, see from on PC number 1, I can say IP DHCP. See the IP address. I'm getting IP address from DHCP server. Yes. What is my IP address? 192.168.1.4. Default gateway 192.168.1.254. DNS server IP 192.168.2.2. So like this, all machine can get IP address from DHCP server now. See 1.5 PC3 1.2. So all are using unique, all have unique IP addresses, correct subnet mask, correct default gateway, correct DNS server IP address. Okay. So these all are, guys, application layer services. And to access it, we have protocol. So first of all, my PC is going to generate one HTTPS message. At which layer? At application layer. Correct? Application. Now my application layer is going to hand over it to lower layer. Next layer is presentation layer. Correct, guys? What presentation layer will do? See, the working of presentation layer is encryption, decryption, right? Means while sending, it will encrypt the data. While receiving, it will decrypt the data. Then compression, decompression. Compression means what, guys? Reducing the size of data. Like if you want to send a movie to your friend, and guys, movie size is 2 GB, let's suppose, and the application which you are using are not supporting 2 GB data. Let's say your application can send up to 500 MB data. Through WhatsApp also you have some limitation that through WhatsApp you can not send 2 GB data, right? So what actually we are doing, we are using different kinds of software like WinRAR, zip file to compress the data, to reduce the size of data. So with the help of zip file, first I will reduce the data, then I will send it to you through WhatsApp. Now to again use that data, first you have to decompress it. Yes or no? If you want to watch the movie, first you have to unzip it. Correct, guys? So actually presentation layer is responsible to perform these kind of tasks. Got it? Encryption means converting actual data into ciphertext. Like my actual data is hello. My actual data is hello. So presentation layer is going to encrypt it. It will use one algorithm, right? We have multiple algorithms for encryption. When we will discuss the security part, we will see we have lots of algorithm, guys, like AES. Algorithm means, like, let's suppose I have one algorithm, and in that algorithm I have designed that algorithm in such a way so that H will be converted into 1, E will be converted into 5, L will be converted into, let's say, at the rate, and O will be converted into, let's say, H. So this is what one kind of algorithm, right? So whenever I want to encrypt the data, I will use this algorithm. So guys, what will be my data after encryption? 1, 5, at the rate, and H. Yes or no? This is my data after the encryption. So if someone will capture the data, they cannot read it until and unless they have this algorithm to decrypt it. Correct? So anyone who want to decrypt this data, they should have this algorithm. So as both machine, sender machine and receiver machine, is designed according to OSI model, right guys? Both will have same algorithm, yes or no? Both will have same algorithm for encryption and decryption. Correct? So this is encryption. So presentation layer is going to encrypt my data. Then when receiver machine will receive it, it will decrypt it into the actual data. How? Again, by using same algorithm that sender machine has used while sending. Then presentation layer is going to hand over data to session layer. Now what is the responsibility of session layer? Session layer. Guys, session layer is responsible to maintain the session, to create the session, maintain the session, and terminate the session. Got it? To create the session, maintain the session, and terminate the session. See, sometime when you are trying to access any website, you are getting request timeout error. Right? So how you are getting request timeout? Actually, whenever you are sending any request from your PC, your session layer is going to create one session, right? Let's say for pmnetworking.in, session timeout is 1 minute. So session layer have information that I have sent one request to 8.8.8.8 and session timeout for this application is 1 minute. Means this machine is going to wait for 1 minute for reply. So if this machine will not receive reply message within 1 minute, then session layer is going to give you one error, that is session timeout. Right? So this is not like, means if I have sent one request to google.com from my PC and my PC is going to, my PC is keep waiting for reply message for entire day, for entire month, for entire year. No, not like that. There is a role of session layer. You have created one session and waiting for your reply. Session layer is running one timer for reply. So if this machine will not get reply within that timer, then it is going to give you error message. Got it? See, in this browser, I have multiple tab. Yes or no? Here I have access of my website. Here, google.com. Here, WhatsApp. Like this, I can have multiple tab in the same browser. Or I can have multiple website, multiple application in the same browser. And see, I have another browser as well, guys, here. Right? This is also one browser. So see, if I am using WhatsApp in this tab, so whenever my computer will get any message for WhatsApp, it will, session layer will hand over it to this session only, right? You will not get WhatsApp message in this tab, right? So my machine have session with multiple servers now, with PM networking server, Google Meet server, WhatsApp server. So how these all sessions are separated with the help of session layer only. Getting my point? With the help of session layer. And after that, guys, session layer is going to create the session, then session layer will hand over the data to lower layer. To which layer? Lower layer means transport layer. And now the responsibility of transport layer is adding source port and destination port. Now question is, what is source port and destination port? What is port number? Correct? What is port number? So guys, till now we talked about two types of address, MAC address and IP address. Now I am going to discuss one more type of address, that is port address. That is port address, port number. Port number. See, try to understand very carefully. It is very important. See guys, MAC address. MAC address. Can anyone tell me MAC address is responsible for which type of communication, guys? Yeah, that is also good. Anything else? Node to node. Okay. This is good answer. Node to node. Node to node. Let's say I have one computer here, two computer, three computer. These all computers are connected with switch. Then this switch is connected with router. This router is connected with another router. This router is connected with another router. And again I have one switch here. And again I have some end devices. So with the help of MAC address, these nodes can communicate with each other. Like PC1 can communicate with PC2, or PC1 can communicate with PC3, or PC1 can communicate with router 1. With the help of MAC address, PC1 cannot communicate with router 2 or with this device. With the MAC address, guys, router 1 can communicate with router 2. Router 2 can communicate with router 3. Router 3 can communicate with router 2. And router 2 can communicate with router 1. Like this. MAC address is for node to node communication. Then IP address. IP address is for which type of communication, guys? Yes. Host to host. Like if this host want to communicate with this host, or this host want to communicate with this host. Host to host. Getting my point? Node to node means my neighboring device. Host to host means one host is in Gujarat and one host is in Delhi. Now there are multiple devices between Surat and Delhi, right? I am in Surat, my laptop is in Surat, someone is in Delhi. There are lots of router, lots of end devices are there. Sorry, router switches are there. Right? So with the help of MAC address, each device is going to communicate with their neighbor device. With the help of IP address, my laptop and laptop of my friend, Delhi laptop, both are communicating with each other with the help of IP address, host to host. Understand the difference between node to node and IP, host to host. Node to node means my neighboring device, and host to host means one host can be a different location, and we can have lots of devices between two nodes. Even though we can communicate with each other, doesn't matter how many devices are there. There can be firewall, there can be switch, there can be router, there can be any other devices as well. And then third type of address is what? Port. So port number is service to service communication. Like see in the diagram, in your packet tracer diagram. On this server, you have one service, HTTP as service, correct? So guys, if this PC want to access HTTP service over here, I will access this service with the help of port number, right? Like on the PC, IP address is this one. On the server, IP address is this one. These two IP address can communicate, means both devices are able to communicate with each other. Now on this PC, I have Google Chrome. On this server, I have HTTP service. How these two services are going to communicate? With the help of port number, right? Let's say PC1 is sending one packet to server. Which type of packet it is? HTTP packet, right? Source IP address will be 192.168.1.1. Destination IP will be what, guys? 192.168.2.1, correct? Source MAC will be the MAC address of PC1. Destination MAC will be router 1, right? PC will forward to switch, switch will forward to router. Router is going to check the routing table and then it will forward to this server. This server will check what? Destination MAC. So when router will forward this traffic to server, it will change the destination MAC, because as I told you, MAC is node to node communication, means at each node source and destination is going to be changed. At each node source MAC and destination MAC is going to be changed. Means when router will receive this message, router is going to change source MAC and destination MAC. When router will forward it to server, source MAC will be the MAC address of this interface, exit interface, right? Router 1 exit interface, and destination MAC will be the MAC address of server, right? So when server will receive this packet, guys, first of all it will check what? Destination MAC, it will remove it, right? That means yes, this is for me. Then it is going to check what? Destination IP. Destination IP is 192.168.2.1. Yes, this is my IP address. That means this packet is for me. Now this packet is for which service? Let's suppose on this server there are multiple services running. HTTP is running, HTTPS is running, right? DNS is also running, DHCP is also running, right? And many more. POP3 is running, SNMP is running. Many services are running. So how this server is going to identify the actual data? With the help of port number. Now it will check port number. So destination port is going to be 443, right? So once this server will see, okay, destination port is 443, that means it is for HTTPS. So this machine is going to hand over it to HTTPS protocol. Getting my point? So is it clear, guys? Port number. Now we have two types of port number. Port number. We have two types of port number. Like we have two types of IP address, private and public. In the same way, we have two types of port number. Well known and unknown. Or you can say free and used. Used port number means the port number which I have already assigned to protocol, to services, like HTTP. HTTP port number is 80. So this port number is already assigned to this protocol. That means this is a used port number. Then HTTPS port number is 443. So this port number is already assigned to this protocol. So that means this is a used port number. Port number of DNS, guys, 53. This is used port number. Port number of DHCP 67 and 68. Don't worry, we will discuss why DHCP is using two port number. So we have two types of port number. One is well known, or you can say used. Well known port number are those port number which I have already assigned to protocol. And the free port number or unknown port number are the port which are free, which are available, right? So if PC1 want to send HTTP message to this server, PC1 is going to add source port and destination port. Source port will be random port number, means free port number, and destination port is going to be well-known port number, which is assigned to protocol, right? And guys, port number is 16 bits value. Port number is 16 bits value. Like IP address, length of IPv4 address is 32, length of MAC address is 48. In the same way, port number is 16 bits information, and we represent it in decimal. So can anyone tell me range? Range can be 0 to 2 raised to power 16, right? Means 0 to 65535, right? So this is range of my port number. And guys, as I told you, we have two types of port number. I divide it into two parts. One is well known. Well known means the port number which are assigned to protocol. So can anyone tell me the range of well known port number? Right. So here, guys, in your scenario, responsibility of transport layer is to add source port and destination port. So tell me what will be source port number? Source port will be what, guys? Source port, random port number. From which range? Yes. So it can be 102, 4, 5, 6, 7, anything, right? 000. So let's suppose source port is 1025. Then, guys, destination port. What will be the destination port? So see the protocol. Which protocol I'm using at application layer? HTTPS. So well-known port number of HTTPS. What is the well-known port number of HTTPS? 443. Done. Now this was the work of transport layer. There are many more tasks as well, guys. Transport layer is going to perform. We will discuss. See, as a network engineer, you are going to master these 3 layers or these 4 layers: transport, network, data link. So our next class, means tomorrow class, will be on these layers only, right? So this is first function of transport layer, adding source port and destination port. After that, transport layer will hand over it to lower layer. Means which layer? Lower layer means network layer, right? And network layer is going to add what, guys? IP addresses. Source IP. Source IP will be IP address of PC1. Let's say 192.168.1.1/24. Router interface IP address is 192.168.1.254. Like this. Right? MAC address of router interface is, let's say, B. MAC address of this PC is, let's say, A. Done. So source IP is 192.168.1.1. Destination IP will be what, guys? Destination IP 8.8.8.8. How this PC will get to know destination IP? DNS server? Yes or no? Because you have entered www.pmnet.com in the browser. So your PC is going to resolve the IP address of this domain name. It will get this IP address 8.8.8. And this is the work of network layer. Now network layer have added source IP, destination IP. Now it is going to hand over it to lower layer. Lower layer means to data link layer. And guys, responsibility of data link layer is to add source MAC and destination MAC. So source MAC will be A and destination MAC will be what? Again, destination belongs to my network or different network? Different network. That means destination MAC will be the MAC address of default gateway, which is B. Right? And now only this PC can send this packet, this message. Right, guys? Because now there is address with actual data. And you know, these information are extra information, correct, guys? My actual information is this one only, right? So when receiver machine will receive this data, receiver machine need to remove these all extra information, correct? So yesterday I told you OSI model tells how data is going to out from the computer. So this is how data is going to out from your PC. This is how your computer have performed encapsulation, means how they have added the extra information, right? After that, data link layer will hand over it to physical layer. Physical layer will convert it into bits, and then it will forward to router. Then router will forward it to internet. Internet will forward it to server. When server will receive, first server will check what? And guys, when router will receive it, router will remove this header and it will add new source MAC and new destination MAC, right? So source MAC will be the MAC address of this interface. Oh, this is IP IP address of this interface here, na? This one. This is the default gateway, na? Okay. And let's say internet, this interface MAC address is C. So yes, router have removed the layer 2 header and now it is adding new header. So in the new header, guys, source MAC will be the MAC address of their exit interface. So MAC address of this interface is, let's say, D. So source MAC will be D and destination MAC will be C. Right? So at each node, source MAC and destination MAC is going to be changed. Each node will add a new layer 2 header and layer 3 header is going to be same, guys. Then router will forward it to internet. Now again, when internet will forward it to server, it will change layer 2 information, means source MAC, destination MAC. MAC address of this interface is, let's say, P and MAC address of server is, let's say, Q. Right? So this server, this internet router is going to add new layer 2 header where source MAC will be P and destination MAC will be Q. Then internet router will forward it to server. When server will receive it, first server is going to check what destination MAC. So destination MAC is Q. It will verify that my MAC address and the MAC address which is coming in packet is same or not. If both are same, then only server will accept it. Otherwise, it will discard it. So in this case, you can see both addresses are same. So the server is going to remove this header. The server is going to remove this header. And guys, there will be some extra information in this header. PC will add some extra information in this header also, in this header also, and in this header also. Right? So here, extra information will be the information about upper layer protocol. Right? Like here information will be that I am using IPv4 protocol at layer 3. Here information will be, I'm using TCP protocol at layer 3 like this. So when receiver machine will check the destination MAC, after that it will check this field. Oh, upper layer protocol is IPv4. So it will remove the header and then it will hand over the rest information to IP protocol at layer 3. Then guys, IP protocol at layer 3 is going to check what? Destination IP address. So destination IP is 8.8.8.8. Again, it will compare their own IP address and the IP address which is coming in packet. Both are same. So it will accept it. And then it is going to check this extra information. Means which protocol is working at upper layer. So there will be information like TCP. So again, at layer 3, IP protocol is going to remove this header. It will remove this header and then it will hand over actual information to TCP protocol. Now TCP protocol is going to check what? Destination port, right? So destination port is 443. Now server is going to check, is 443 service enabled on me? Is this service running? If yes, then it will accept, otherwise it will discard. So as the service is running on my server, simply TCP protocol is going to remove this extra information and it will hand over actual data, actual HTTP data to HTTP protocol. And now guys, HTTP protocol can understand this message, right? This is the actual message at application layer again on the server. HTTP protocol can understand this message. It can read it that, okay, this is a request message. Someone is trying to access the web page. Let me send the reply. So HTTP protocol is going to generate again HTTP reply message, HTTPS reply message. Again, same process will happen on this server, right? It will hand over to presentation layer, then session layer, then transport layer. Transport layer is going to add source port, destination port. What will be source port? 80. What will be destination port? 1025. Yes or no? Because this time the server is generating traffic. So source is 80, well known. Destination is the random port number which PC1 is using. And you know, session layer, on this PC session layer have already information that I have sent one request to 8.8.8 where source port is 1025. Let's say this PC have sent one request to this server and there is one more server whose IP address is 3.3.3.3. In the same browser guys, in the same browser on this PC, I have two tabs. One for 8.8.8.8 and one for 3.3.3.3. So session layer have information that I have sent two requests to server. Here source port number is 025. Here source port number is 26. So when this machine will receive reply where destination, where destination port is 1025, it is going to put that in tab number 1. If destination port is 1026, then it will put that reply in tab number 2. This is how session layer is separating each session as well. On PC, your PC is maintaining it. Yes. If you have sent an HTTPS request from the router, then the router is going to maintain it. Okay. No, see, here you have, let's suppose another PC whose IP address is .2, right? So router will forward .1 to this PC, .2 to this PC. So router is going to decide it now. So router will forward traffic to PC on the basis of IP address. Correct? And your PC is going to identify the actual message with the help of port number. Clear? So if there is one more PC, so IP address will be different, right? Here if my media is Ethernet, then physical layer will convert my actual data into bits and then into electrical signal. Because data travel on Ethernet link in the form of electrical signal. If let's say this device is connected with router through without wire, wirelessly, then physical layer is going to convert your data into light signal. Getting my point? So depends on media. Physical layer have capability to detect the media, and on the basis of that it will convert your data into bits or into the light signal or into the electrical signal. Yes, ask me. the entire thing, source IP, destination IP, source MAC, destination MAC, source port, destination port, everything done. First it will convert, physical layer will convert your data into bits, and then bits into signal, right? So physical layer means not only cable. If someone asks you what is physical layer, so this is not physical layer, is a media or cable. Physical layer have multiple functions, right? Like physical layer can detect the line protocol, guys. As I told you, line protocol means my neighbor device port is up or not. So physical layer is the layer which detect line protocol. Physical layer is responsible to check the media, that media is working fine or not. If media is not working fine, if there is no connectivity, then physical layer is not going to convert your data into bits. It will discard it. Because why it will use their CPU? Media is not working, so it is going to drop it. Before sending data, it will detect the link. So line protocol should be up, their status should be up, then only physical layer will convert your data into bits. Right? So now guys, tell me the overview. Use of application layer, user interface, correct? We have multiple services. We will see lots of services we have at application layer, and we can access those services with the help of protocol. Presentation layer, encryption, decryption, compression, decompression. Session layer, creating, maintaining, and terminating the session. Transport layer, responsible to add source port, destination port. Network layer, responsible to add source IP, destination IP. Data link layer, responsible to add source MAC, destination MAC. Physical layer, responsible to transmit the data on link. Clear?